on that question concerning our belief in protein. Way back in 1924, 1920. By the way, protein was discovered in 1839. The name protein comes from the Greek word first. For some reason, at that time, it was, that's another whole story. But in any case, we started believing this really tremendous, that protein had this almost tremendous value. Finally, in 1924, a fellow came up, a professor at the University of Illinois, actually, with a method for determining the value of protein. He called it biology and value of protein. And he basically was able to show that the more protein that we consume that is actually retained by the body, more protein consumed that's retained, and they have a way of calculating that and measuring it, the greater the body weight gain. That's good for livestock production. That's good for livestock. I know that. I came from a farm. More protein gives a faster rate of gain for pigs and chickens, more milk and so forth. More profit for livestock agriculture. And so what did that lead to this word here, high quality? So a lot of people subconsciously, a lot of people haven't even heard of this idea, but almost subconsciously they believe that the protein from animals is high quality. Plant proteins are not, because they don't have this high quality, that is less retained, okay? So animal protein becomes the protein to consume. If you want good protein, get it from animals. I'm saying that's nonsense, because it all has to do with amount retained. Yeah, body weight gain, if people kind of attracted to that idea, like to go a little bit faster, but that's another lecture or two. The fastest rate of growth in our children is in fact not the best rate of growth. The fastest rate of growth achieved by consuming more animal food is crazy. So let me just show you now what we know. A higher retention of the protein increases the production of growth hormone. I showed you that in our research we did ourselves. A higher rate of protein retained increases the level of estrogen in the blood. More estrogen in the blood means more breast cancer and a lot of other things. The higher the protein retained, the greater the so-called production of these oxygen-free free radicals. Okay, more mutations, decrease in natural killer cells, decrease in DNA repair. So all these mechanisms here come from more protein being retained. Animal proteins retain more protein, plant proteins do not. So animal protein, when we consume, more of the protein is being retained, more than we need, and the wrong kind of protein on top of it. And it kicks off all these effects here. This is all published. It's not just imagining things, and not just hypothesis. This is real published stuff. All these mechanisms here are increased by the consumption of high quality protein, animal protein, increases cancer. Increasing higher retention of protein also increases blood cholesterol, total cholesterol, bad cholesterol, LDL cholesterol, associated with heart disease. By the way, that was discovered in about 1909. We've known that. It's not saturated fat. That's not it. It's not total fat. It's animal protein. It's a desire to consume animal protein. And that specifically was concluded in the early 1920s. It's animal protein that causes increase in blood cholesterol, not the fat. Okay, one more thing. Animal protein, more protein being retained, it increases blood sugar too. And A1C, the measurement of diabetes risk, as many of you may know. So here's animal protein. More of the protein is being retained, it's got higher biological value. It's higher quality. Everybody hears that. Higher quality, you've got to have it. Okay, you can have it. You can have all these things here too, or go along with it. More cancer, more heart disease, more diabetes. How about it? Unfortunately, this information coming out in the last 30 years, I'd say 40 years, during the time that I've been involved in my research, no one wants to hear this. The scientists don't want to hear this. And even the authorities who are making judgment about how much protein we consume, they don't want to hear this. Let's put the question concerning high quality animal protein, that story to rest. And so here's what we get. This high quality animal protein that we all want, we just want this here. This is what we get. You know, they see the picture, chickens and pigs and cows now being grown en masse, if you will. But you know, if you look on the web right now, the big story about livestock production, it seems to me, a lot of these reports, is how are we going to meet protein demands in the future? Because around the world, people still want to get that high quality protein. They think they really need it. And so this stimulates these kind of industries. They play off that sort of narrative, that understanding, as if we need more protein. This is especially true among countries that have, until now, haven't consumed that much animal protein. So that being said, that is associated with sickness. That's associated with sickness. So what do we do with our sickness? Well, over the years, we've tended to want to use drugs, basically to control our sickness, okay? Let me just show you a couple of things here just to get you thinking. Here's the use of pharmaceuticals. The dollars spent per capita for drugs for different countries. We're the highest country in the world using pharmaceuticals. In other words, we would use all these drugs to resolve the sickness problems that we get from eating the wrong food. It's very clear. I can't see how anybody can really look at that and see anything different. The United States is the only country, too, in the world who advertises on TV direct-to-consumer advertising of drugs, prescription drugs. I say the only country. There was a second country, New Zealand. I was actually on a podcast with somebody interviewing me from New Zealand who told me that they're now changing that. So I think it's fair to say that the U.S. is the only country in the world who advertises prescription drugs on TV, advertises TV. And the FDA administration themselves confess on their own website that when they see these ads coming for new drugs, they see those ads about the same time as the public does. In other words, they don't get a chance to comment on them. Prescription drug side effects, we now know, is number 3. Some judgments, depending on how you count it, number 4. But prescription drug side effects are serious. We use the wrong nutrition, create sickness. Okay, we create sickness. Now we got drugs, and want to fix this up. Okay, we're spending the most on drugs. We advertise on TV. Everybody buys into this narrative. Drug side effects alone is the number 3 cause of death, for crying out loud. So what does this all mean? I'm just looking at different metrics. This is a comparison of 39 of the Western sort of affluent countries comparison. But life expectancy is quite a ways down the list here. We're consuming all this protein, all this protein. We use a lot of drugs. What are we getting for it? We sure ain't getting increased lifespan. This has been declining. During the pandemic, it declined even pretty sharply, according to a report I just saw a couple of days ago. So things aren't squaring. There's something's wrong. So what's the rationale for drugs? Let me turn your attention for drugs. A little bit of the biochemistry. Keep in mind, I was in essentially the pharmacology community in the first 10, 12 years or so. That was my primary interest. Here, I'm going to just develop for your thinking. This is a scheme of showing reactions that go in the cell to deliver energy to us. We capture the sun's energy. Plants do that, by the way, in photosynthesis, as you know. And they capture that solar energy and convert it into chemical energy. And one of the first products that's produced in that chain of events is glucose, okay? And then this subsequently now loaded up with energy. The energy is in the chemical bonds. That's gradually broken down step by step by step on through here. We call it glycolysis, the first part, just in the absence of oxygen. This down here is in the presence of oxygen, Krebs cycle. Some of you may have seen this. When I was first on the faculty back in the 1960s, in fact, I actually taught this. I taught biochemistry for the biochemistry students, and it was quite exciting. In those days, we just had access to not a whole lot of this information. Pretty simple, bunch of reactions, kind of exciting, actually. To see which step did what, and we could learn which reaction did what, and maybe learn something about how to control things. So the energy from the sun, solar energy, in this miraculous, beautiful, natural thing called photosynthesis, the plants capture that energy, convert it into chemical energy, and then this is all for us, all for us mammals. I'm talking about non-human mammals as well as human mammals. We all do the same thing, which is rather odd. Why would we want to consume, why would this mammal, the humans, why do we want to consume other mammals to get the energy we can get ourselves? I mean, they go big and strong and everything else. It makes no sense on that score. Okay, some years and not too long, maybe 15, 20 years later, those reactions grew. Look at this. This is the chart. Now, this is probably only 1% of the reactions. You can't see all these. The reactions that go inside the cell is all this stuff here. This huge amount of reactions. Beyond, we can't even visualize it. The drug protocol. Now I'm going to speak to the question concerning the use of drugs. Here's how the use of prescription drugs are developed, how they're sold, how they're recommended. The drug protocol, right, to a large extent, not entirely, but to a large extent, it relies on the concept of targeted drug therapy. You may have heard that these days. Where if we could identify some reaction in this mix here that might have something to do, with forming something we don't like, okay, that's what I was doing. We're looking for the key reaction. Well, okay, let's say some researchers found a key reaction here. Okay, then we get some chemical to block that reaction. And what do we get with it? Maybe you can block it for a little bit. What do you get? You get a bunch of side effects. All drugs have side effects. That's why the third leading cause of death in this country, fourth, depending on how you count it, one of the leading causes of death in this country is side effects from drugs. One could do a lot better job with nutrition, not drugs. So the nutrition protocol or food protocol, in this case, we got multiple nutrients, no side effects. Drug protocol, one reaction, one drug, multiple side effects. Down here, here's nutrition. Multiple nutrients, no side effects. How can one look at this and then keep a straight face? You can see the difference. It's huge. So let me give you an example. I just come back to this chart I showed you before. Some years ago, it was discovered that serum cholesterol, as I said, over 100 years ago, the higher cholesterol in the blood would lead to heart disease, right? So longer in the 1970s, 80s, or something during that period, they learned something about the synthesis of cholesterol in our body. We make cholesterol. We need cholesterol, but we make our own, okay? We don't have to consume it, by the way. We make our own. So it starts out with this little compound here called acetyl-CoA, which then goes through a series of reactions to eventually get serum cholesterol. And the thought was, and this is the pharmaceutical sort of idea, the thought was if we could find a reaction here in this stepwise thing somehow to block it, maybe, that would be a good idea. Then we could take that drug and block cholesterol formation, which presumably leads to heart disease. It does not, by the way. It associates with heart disease, but there's something more going on with heart disease, not just the cholesterol itself. Anyhow, we look for something like this, along by the late 80s, statins. There we have nice industry now, a few billions of dollars, tens of billions of dollars. People taking statins to stop cholesterol in the blood. What is it doing? Statins have side effects. Why would we take something like that? This is probably the number one drug there is, I guess, from what I see. We've used statins for quite a while to block heart disease. And the results we get from that is nothing compared with what you can do. What Dr. Essett and Dr. Ornish have shown. You can actually reverse heart disease with nutrition, with a whole food-based diet.